going to learn about how to add integers without manipulatives. So in the past, you might have learned how to add integers with integer counters. You might have learned how to add integers with number lines. Now we're going to learn how to do it without either of those tools so that we can start adding bigger and bigger numbers, right? We don't want to use integer counters for an expression like 100 plus negative 72. I personally don't want to be drawing 100 positive and 72 negative integer counters. I'm sure you don't either. There's better uses of our time, right? So we're going to learn rules to help us do it without those counters, but keeping those models in mind help us formulate the rules. So in class, we just set up all of our expressions on the board and we noticed something, and we noticed our rules. So the first thing is if the integers in the expression are the same sign. So what does that mean? That either means that you have a negative plus another negative number, or you have a positive plus a positive number. Well, what happens? So if the integers in the expression are the same sign, then you add the integers as if they were both positive and keep the original sign. So keyword here is add. If they're both the same sign, we add the integers as if they're both positive and keep the original sign. So I'm going to do two manipulatives to show you this, right? So an example could be 3 plus 1. So if I did 3 plus 1, how would it look with integer counters or IC? Well, it'd be 1, 2, 3, and 1. There's no opposite signs, right? They're all green, so there's no red to counteract the green. So what do? What we realize is we just combine them. We get more, and combine means add. So when they're all the same sign, we simply combine, or AKA add, to get our new amount. In this case, instead of 3, I have 3 plus 1, which is positive 4. Since 3 and 1 were both positive in the beginning, I keep the positive in the answer. What about this? Negative 3 plus negative 1. Well, what does that look like on an integer counter? Again, that's 3 negatives and 1 negative. There's no green to counteract the red. Simply what I have is I had 3 negatives and now I added 1 negative. I combine them because there's no canceling. Remember, combine means add. So in my head, I combine them. What's 3 and 1? Oh, that's 4. But since they were originally negative, I keep the sign negative. So I ended up with 4 negatives. So what does this look like on a number line? So NL means number line. So if I was to do a quick number line, which I will, here's 0. What would happen with this 3 plus 1 is I'd go forward 3 and then forward 1. So again, I'm moving in the positive direction and I combine those movements or add them together and still remain positive. In this case, as we know, it would be positive 4, right? Well, what does it look like if it was negative 3 plus negative 1? Well, here's 0. I would go back 3, then back 1. Again, I'm combining, but this time in the negative direction. So my answer is negative 4. There is 0 counteraction, right? They're combining to be 1. So if both your signs are the same, you add them and you keep the same sign. Combine is the main word. Combine, 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 combine. And oops, excuse me. Whoa, that was not what I wanted to do. And combine means add. So that was our first rule. That was our first rule. Same sign, add or combine. All right, I'm going to put a rule number 1 off to the side so you know that it's one of our options. Put a little bubble around it. So now let's go to our second rule. Our second rule is if the integers in your expression have, I forgot an N, excuse me, opposite signs. This is what we saw a lot of in our warm-up in class. If your integers in your expression have opposite signs, so what does that mean? That means negative plus positive, or vice versa, right? Positive plus negative. I don't need to write it both ways. Then you subtract the integers. And your sum matches the integer with the higher absolute value. So there's a couple things here. Opposite signs. Well, opposite signs mean we subtract or means they cancel each other. And we're also going to show this on our integer counters and our number line. So let's do that first, and then we can see what happens. So with IC, let's say we have an expression of 3 plus negative 1. Well, what does that look like in integer counters? In integer counters, that looks like 3 positives, 1 negative. So I do have a pair that cancels out. That is where the subtraction comes in. Cancels means subtract. Okay, so what am I left with? Well, what is 3 minus 1? 3 minus 1 is 2. Now, is it positive 2 or negative 2? It is positive 2 because positive 3 has a bigger absolute value. You're left with more positives because you had more positives to start with. Only one negative counteracted one positive. What does that look like on a number line? So you go forward 3, and then you counteract that with 1. Guess where you still end up? Positive 2. You still end up in positives, right? So because you started with more positives in your expression, or your absolute value of 3 is definitely bigger than the absolute value of negative 1, which is 1, we end in positive. So it matches the number with the bigger absolute value. In this case, that was 3. Well, what if you have an expression like this, negative 3 plus 1? Well, again, I see their opposite signs. So in integer counters, right, I would go, 3 negatives, 1 positive. I do have a counteracting pair. Counteracting, remember, means cancel, or subtract, right? Well, what is 3 minus 1? 3 minus 1 is 2. However, in this case, it's going to be negative 2. Why is it negative 2? Because negative 3 and 1, 3 has bigger absolute value. The absolute value of negative 3 is 3. The absolute value of 1 is 1. Right? So we're going to have more negatives than positives because only 1 positive counteracted 3 negatives. That means I'm going to end with more negatives. So it's -2. What does this look like on a number line? Well, on a number line real quick, and again, this is a very quick sketch, we would go back 3 and forward 1. What happens? Again, I end in the negative because only one positive is there to cancel out 3 negatives. That's not enough. So therefore, I still end in the negative, right? -3 has a bigger absolute value than +1. So I'm going to end in the negative still. All right. So these are our 2 rules. I'm going to put a big 2 right here in black. These are the 2 rules that you must write down in your notes. Same signs, add. Opposite signs, subtract. Now we're going to learn the steps for if you get higher level problems. So what's always your steps for solving these problems? Step 1. Identify if your integers have the same signs or opposite signs. Why is this important? Well, we learned there's 2 options from this branch, right? So after step 1, there's kind of 2 options here. So I'm going to do this. If they are the same sign, I'm going to put a little arrow there. Step 2 is you add your integers as if they were positive. Then step 3, you check your sign. And match it. Again, if you start out positive, you end positive. So if you start positive, you end positive. If you start negative, you end negative if they're both the same sign. So that's one option, but what if they're opposite signs? Same signs is green notes, opposite signs is going to be blue notes. Well, then you have different steps, right? These kind of go to our rules. But the very first thing is, well, what are they? Are they the same or opposite? Because that dictates where you go next. Well, if they're opposite signs, you take the absolute value of each integer and circle the larger one. Now, this is going to come into play later. Step 3, you then subtract. Now, the biggest mistake students make is they just subtract like free willy. We always subtract our bigger value and then our smaller, or our smaller from our bigger value. So this bigger value is going to be the one you circled. That always goes on top. The one you circled is the one that goes on top. Because we are going to subtract as if they're positive. Now, what's step 3? Step 3 is to check your sign and make sure it matches your original sign of circled value. Again, that circle comes back into play. So in step 2, you circle the one that has the bigger absolute value. You use it in step 3 and step 4. Oops, I said step 3 twice. You use it in step 3 and step 4. All right. So we're going to do these together. We're going to do one of each, and then we're going to come back to class and practice some more. So let's do example A. Example A is going to be 273 plus 158. So the first thing I do is I look at my integers. I notice, and you can still color code if you want, this is positive and this is positive. What does that mean? Step one. That means these are the same signs. I instantly identify that. Because if they are the same signs, then what do? I add my integers as if they're positive. In this case, they are, but that's great. So I stack 273 plus 158. I would get in the habit of always stacking your bigger number on top, since you have to do that with subtraction. The more you practice proper form, the better it is. 8 plus 3 is 11. 7 plus 5 is 12, then 13. 2, 3, 4. So my answer then is 431, and I make sure whether it's positive or negative. In this case, since the original two values were positive, it stays positive. So my final answer is 431. That's it. That's all it is. Let's do example B. Negative 32 plus 527. So similar to the last problem, I'm going to identify whether my integers are the same sign or opposite signs. From this problem, I see I have a negative 32 and a positive 527. That means they are opposite signs. So what I'm going to do is I'm going to take the absolute value of both. I have the absolute value of 527 equals 527, and the absolute value of negative 32 equals 32. Which one's bigger? I'm going to highlight it instead of circle it, but either way works. It's definitely the 527. Or if I go back to the expression, the positive number. Why is that important? Because that means my answer will be positive, right? I have more positives than negatives, so I'm going to end in the positive. That's all it is. All right, so now we subtract. Well, which one's bigger? The highlighted one's bigger, so I do 527 minus 32. 7 minus 2 is 5. 2 minus 3 I can't do. I got to borrow. 12 minus 3 is 9. 495. So my answer is 495. Now, is it positive 495 or negative 495? It's going to stay positive 495 because I had more positives to begin with, or positive 527. All right. I hope this makes sense. Please come back to class and we'll practice some more. Thank you.